Our story today starts in the late 1990s, when the idea for what would become the Vera C. Rubin Observatory started to emerge. At the time, researchers were looking for ways to explore dark matter. Dark matter is a substance that only interacts with ordinary matter, like the matter here on Earth, gravitationally. As researchers were trying to find new ways to explore dark matter, they made observations of supernova explosions that hinted that the expansion of the universe is actually accelerating. These observations implied the existence of a mysterious dark energy that permeates all of space. If we take all the forces that shaped the universe, scientists currently believe that the universe is made up of about 5% ordinary matter, 27% dark matter, and 68% dark energy. In this case, the term dark applies because it doesn't appear to emit, reflect, or absorb light, and scientists aren't yet sure about how to directly detect it. In order to get some more insights into dark energy and dark matter, astrophysicists realized that they would need to map out the large-scale structure of the universe and its changes over time. Where were they going to start? In 2003, Steve Kahn, an astrophysicist working on the subject, joined SLAC. He brought with him the idea that SLAC and the Department of Energy should engage in the development of a large aperture wide-field telescope that could probe at the very nature of dark energy and dark matter. Along with his fellow researchers, Kahn spent the next decade building out an international network of scientists and researchers to begin working on how they could bring the telescope to life. While the telescope itself is being built in Chile, the centerpiece camera module is being assembled right here at SLAC, using parts developed at SLAC and at other institutions around the world. As you can see from this map, the coordinated effort it took to bring together so many widespread teams was an enormous feat. The centerpiece of the telescope would be its camera module. In the early 2010s, after all their preparation, SLAC researchers and their collaborators in the US and in Europe began prototyping the camera. The camera was designed with a sensor of 3,200 megapixels, making it the largest camera ever built for astronomy. For comparison, the smartphone you might be watching this on right now probably has around 12 megapixels. Using this powerful new camera, researchers plan to capture one image every 30 seconds. Now, I know that may not sound very fast, but remember they're photographing into deep darkness. They need a longer shutter speed for this. Once they have all these images, scientists will produce a very high-resolution image of the southern sky every 3 nights. Ultimately, the plan is to run it as a 10-year project. That means that over the course of those 10 years, the camera will capture the entire southern sky over 1,000 times. This process will create a detailed map of the night sky, revealing how matter is distributed throughout the universe, as well as charting changes in the sky and matter over time. These observations will help researchers understand the nature of dark matter and dark energy. But that's not all. The telescope and its camera will help astronomers map out a lot of transient phenomena, like exploding stars and asteroids whose positions change from night to night. A helpful way to think of it is kind of like a 10-year-long movie of the universe. This 10-year survey is called the Legacy Survey of Space and Time, or LSST. And the camera module itself has come to be known as the LSST camera. In order to design electronics for the new detectors, LSST camera researchers collaborated with teams at SLAC and at the Department of Energy's Brookhaven National Lab. They also worked closely with the Department of Energy's Lawrence Livermore National Lab to develop some of the largest camera lenses ever built. Now, after 2 decades of work, the LSST camera is complete. Then, it'll be shipped to Chile and finally ready to take the most detailed images of the night sky ever produced. If all goes according to plan, that'll happen sometime in 2024. Over its 10-year run, the LSST camera and the Vera Rubin Observatory are going to have a huge impact on the field of astronomy by cataloging roughly 20 billion galaxies. That's around 10% of all galaxies estimated to exist in our observable universe. And no one knows for sure what we'll discover, but it's a really exciting time for astronomy. And we're glad you're on this journey with us now. To learn more about SLAC, check out our other videos in our history series, as well as our explainer videos that give more insight into the science. And please subscribe. You can also follow us on Instagram, Twitter, Facebook, and LinkedIn. Thanks for hanging out with us today. See you next time.